Welcome. In this video, we will be introduced to a geometric series. Geometric series is probably the third most important type of equations that we will use in Algebra 1. Let me pull up here just to show you an example here. We first learned in Algebra 1 a linear equation. Let's say y equals x minus 2, okay? As you can see here, here's an equation here. This is a linear equation. It's a nice straight line. Whoops. Let me zoom, sorry. Now, secondly, we learned a parabola, a quadratic equation. Y equals x squared, let's see, about minus 2. Let me actually drop it down just a little bit so we can see. Now, we see the growth changes as we go along the parabola. It's actually a negative slope on the left side of the parabola, and on the right side of the parabola, it's increasing. Now we're going to look at a geometric sequence. Let's see, we'll do like a real basic one here. And let me drop it down a little bit so we can kind of see the growth. Now, if you can see the green line, this is a geometric sequence. It actually grows. Sorry, I need to turn my mouse off here. Now, the green line is geometric sequence, and it actually starts off growing very slowly, and it starts to grow very fast as you go along. As you can see, the blue line it's pretty steep, but look at the green line. It gets closer and closer to the blue, and eventually the green line here actually gets in front of the blue. It's actually going steeper now. The y values are actually higher. Have another graph here. Just look at example of a geometric series where the numbers increase by a common ratio. If you look at the geometric series here, I have 10, 20, 40, 80, 160. Each time they're doubling. And here's just an example of a graph here of arithmetic growth. And we see geometric growth. So geometric growth started off below the arithmetic, but then it eventually passes it. Now, geometric series is used frequently, especially when it comes to money problems, like maybe investments or stocks. For example, let's say you have a stock that's worth $10,000, and it appreciates each year by, let's say, 10%. Say there's a 10% growth. Well, after 1 year, it would be 10% of $1,000, which is 1,000. We're going to add 1,000, so we now have $11,000. And after the second year, let's say it grows at the same rate of 10%. Well, 10% of $11,000 is $1,100. We will add that to the $11,000, and we get a new total of $12,100. Now, the numbers keep changing because each time we're adding in the same percentage, but the numbers will grow faster and faster. And with a geometric series equation, or even I should say a sequence equation, because series is actually the sum, the sequence are the numbers, we can find out later how much money we would have in the third year, the fourth year. Maybe you want to look ahead. Maybe you want to retire in 30 years. How much would you have in 30 years? Well, you can use equations with this geometric to actually find the answer. We could not do that as a linear equation because a linear equation has a constant slope, keeps growing at the same rate. But the geometric, it speeds up. Or it could also slow down. It could slow down. Now, geometric series are also useful because we find a lot of infinite series where we see something, it keeps changing, and it could change perhaps forever. And then that's where you get into a term called infinite series, and that's part of a geometric series. Let's see. Give an example here. Let's say one person catches a code. And this person can spread it, okay? He spreads the code to 2 other people. And this person, both of those people can spread it to 2 other people as well. They can keep spreading to 2 other people are infected by the first 2. So if I were to draw a picture here, here's one person. He spreads it to 2 other people. These 2 will spread it to 2 other people. and so forth. And we could keep going for a long time. And let's say, I'll just kind of give you some numbers here. Let's say we know that about every 15 hours, the next round of people are infected. Okay, so another round of infection of codes occur. And I may ask after, let's say, after 4 days, excuse me, I guess I said 15 hours. Say after 60 hours, how many people will have a cold? We know that this will be 4 iterations. There'll be 4 iterations or 4 rounds. And using a geometric series equation, we can actually calculate exactly how many people are infected after 4 rounds. And that's the usefulness of a geometric series. Now, the basic geometric series follows this pattern. We use the term a sub n is equal to a sub 1 times r raised to the n minus 1. A sub n is whatever term we're trying to find. Like maybe we're trying to find the first term, the second term, the third term. N is the term number. R is the common ratio. Are the numbers doubling every time? Are they going by a half every time? Are the numbers tripling every time? That is the R. And A sub 1 is the first term. So I'll give you an example. Let's say we have one person who has a cold, and this person gives it to 2 other people. And those 2 people will each give it to 2 other people. Okay, this is like these are all the new infections. And these 4 people are going to each give it to 2 other people, and now that's going to be 8. Okay. And let's say we can just model this very simple. And this is the most basic one. We're not finding the total because if one person affects 2, it's actually 3 people infected. And then the next round, we have to add 3 plus 4 to get 7. We're not doing that. That'll be in a later video. So let's see. The way we're going to write this basic equation is the first term. Common ratio, each time the numbers are doubling. And let's say, let me see up here, n minus 1. Let's say I want to find the ninth term. What is the ninth term? Well, we write it as a sub 9, the ninth term, will be the first term, which is starting with 1. Each time the numbers are doubling, and we're going to raise it to the 9 minus 1, because the n tells us which term number we're trying to find. So this becomes essentially 1 times 2 to the 8th. Oops. 1 times 2 to the 8th. And what would that be? Let's see, I'm going to cheat here. 1 times 2 to the 8th, and it is 256. So there'll be 256 new infections by the 8th iteration, or the 8th term. And this would be after, let's see, well, we don't know how many hours it takes for each person to catch a cold. Okay. Now let's look at the worksheets now. All right. Now, the homework for this time around will be over the reading strategies. It says, study the information below. In a geometric sequence, we're just seeing a series of numbers here. We see here 1, -4, 16, negative. Now, these numbers are changing signs. A geometric series, the numbers could get bigger, they could get smaller, and they could even change signs. Each time, as we can see down here, we're multiplying by -4. That is why the signs are alternating. And because we're multiplying by the same number, this is what's called the common ratio. We give it the letter R. Here's our basic equation over here. Common ratio is R is -4. To find the 10th term, we use this A sub n equation. So it's A sub 10 is equal to the first term times the R value of -4 raised to the 10 minus 1. Now this value and this value will always be the same. It'll always be the same number. So let's look at the first question. What is the first term for this geometric sequence here? 2, 6, 18, 54. Well, the first term is the number 2. What is the common ratio? What are we multiplying by each time to get to the next number? We're multiplying by 3. And let's say we didn't know that. Well, each times we have to times it by the same number. I'll call it r. So 2 times r has to equal 6, the very next number, because we're going from 2 to 6 to 18 to 54. If we solve for r, we're going to divide both sides by 2, and we get r is 3. So we know the common ratio is 3. And it says here how to describe how you found the common ratio. Well, I would just say the same thing. We did 2 times r is 6. We divided both sides by 2, and r is equal to 3. Now, what is the next term? Well, we know it's 54 right now, and the next term is going to be 54 times 3, the r, which is going to be 162. It says use the formula to find the 12th term. So we do a sub 12. Excuse me, write the equation first because this is our first time seeing it. A1 times r to the n minus 1. And we know the first term is going to be 2. Each time the common ratio is going to be 3. And I use a parentheses because we're going to raise it. We're trying to find the 12th term. So it's going to be 2 times 3. And the 3 will be raised to the 12 minus 1. So we'll do 2 times 3 to the 11th. And what would that be? Let me pull up our calculator here. So it's going to be 2 times 3 raised to the 11. And I'll have it equal. And there's our number. It's going to be 354,294. Let me write the answer over here. 354,294. At least I think that's what it said. Hope that's what it was. There we go. Number 6. The numbers 6, 9, 12, and 15. Is this a geometric sequence? Are we multiplying each time by the same number? Well, we could test it simply. 6 times r has to equal 9. We divide both sides by 6, because 6 is the first term, 9 is the next term. If we divide it, we get r is equal to 9 over 6, which is 3 halves. If we multiply 9 by the common r ratio, which is 3 halves, we should get 12, because over here 9 times r gives us 12. Well, let's see what 9 times 3 halves is. Well, this would be 27 over 2. And that's 13.5. It is not 12. So this is not. But what kind of sequence is this? This goes back a couple chapters. We did arithmetic sequences back in chapter 4 or 5. Each time here, we're adding plus 3. Plus 3 and plus 3. So no, this is because we're adding, this is also like kind of it's an arithmetic sequence, which is also like a linear equation. There's a constant slope of 3. Or we'll call this a arithmetic sequence. Just as a reminder, because it's been a while, if you're adding the same number or subtracting the same number each time, that is an arithmetic sequence. But when you multiply or divide by the same number every time, that's a geometric sequence. Number 7, find the 8th term in the geometric sequence. Well, we first have to identify the first term, which is 5, and we have to figure out what the common ratio is. What would you multiply to get to negative 10? Well, if you multiply by negative 2, so we know the first term is 5, and the r value is negative 2. So we're going to write the 8th term will be equal to the first term, which is 5, times a common ratio of -2, and we're trying to find the 8th term. So it's going to be n minus 1, which is 8 minus 1. Now, if you kind of forget, you could always pause the video or rewind it and go back and just look at the basic form of the equation, which we can actually still see up here. Here's the basic form that we're using every single time. Sorry, that looks horrible. That's a little better. So now we're going to get 5 times a -2 raised to the 7th. Let's see if we can clear that there. It'll be 5 times, put a parentheses here, a -2, I have to do a plus minus key, raised to the 7th. And we get minus 640. Minus 640. Number 8. The first term of a geometric sequence is 14. The common ratios are find the 5th. So we're just going to go back and use our basic equation up here again. We're trying to find the 5th term. So a sub 5 will equal the first term, which is 14, times a common ratio of 6 raised to the 5 minus 1, which of course means we're going to raise it to the 4th. So let's see here. We're going to do 14 times 6. I should do a parentheses. Raised to the 5 minus 1, which is 4. Raise it to the 4th. And now we'll get 18,144. Number 9. Find the 9th term in the geometric sequence. The 9th term. We know the first term is 256, but what's the R value? Now we could do the R at any point. I think I'm going to do it from here to here. It'll make it easier. The numbers are smaller. 64 times R equals 32. Now we're going to divide both sides by 64. We'll divide both sides by 64. And we get R is equal to 32 over 64, which reduces to 1/2. So this sequence is getting smaller, as we can see. It's a decreasing sequence, also known later we'll use the word decay. It's either these sequences could be growth, where they get bigger, or they could be getting smaller, which is called a decay. Now let's find the 9th term. Well, a sub 9 is going to equal to the first term, which is 256. And the common ratio will be 1/2. And we'll raise it to the 9 minus 1. So let's see. We use our calculator here. We have 256 times, to parentheses here, I'll do 1 divided by 2, close the parentheses, and raise that to the 8th power, because it's 9 minus 1. Oh, and the answer is 1. So this sequence, as it gets smaller, as it went from 32 to 16 to 8 to 4 to 2 to 1. That is the 9th term, starting from 256. Let's look at practice A worksheet. For number 1, they give us a series of numbers, or excuse me, a sequence of numbers, 1, 4, 16, and 64. It says, what is a common ratio? Well, each time we're multiplying by what number? The common ratio is simply 4. Let's look at number 2. We go from 10 to 100. 100 to 1,000 to 10,000. Each time we're adding a 0. To add a 0 to the number each time, we just have to multiply it by 10. So the common ratio is 10, which also means r equals 10. I can write that over here too. R equals 4. Number 3, 128. And it looks like it's getting smaller. What is the common ratio? I'll look at 32 to 16, because 16 is half. So I know the common ratio will be 1/2. These are all geometric sequences, so we don't need to verify. Number 4, we go from 4 to minus 20, minus 20 to 100, 100 to minus 500. If we do 4 and we times it by the common ratio r, we will get to minus 20. So what would r equal? We divide both sides by 4 and we get negative 5. So the common ratio is negative 5. Now, number 5, we'll start using our equation. A sub n equals a sub 1 times r raised to the n minus 1. Says the first term is 2, and it's growing by a factor of 4, or common ratio of 4. Find the sixth term, which is 6 minus 1. So I'll write it as a sub 6. So it's going to be 2 times 4 to the 5th. 2 times 4 to the 5th. Let's try that. So we do 2 times 4 raised to the 5th. And we get 2,048. Number 6. The first term of a geometric sequence is negative 3, and the common ratio is 2. Find the 8th term. Now, it's a good time to, of course, as we do each problem, is you could always pause it and try the next problem, and then play the video, see if you get the same answer. Let's see here. We'll use the same equation as always. A sub n equals a1 times r to the n minus 1. It says find the 8th term, which is a sub 8. And by the way, when we say this numbers on the bottom, we call these subscripts. And of course, these ones up here are called superscripts. So the subscripts, we can say it as just sub. So we say a sub 8. You could say a subscript 8, but you always hear the term a sub 8 or a sub n. So a sub 8 is equal to the first term, which is negative 3. The common ratio is 2, and we want to find the 8th term, which is 8 minus 1. So we're going to do here a negative 3 times, I'll put parentheses 2 here, raised to the 7th. And we get negative 384. Now let's look at number 7. The first term is 7, and the common ratio is negative 2. Find the 9th term. So we're going to do a sub 9 is equal to the first term, 7, times a common ratio of negative 2, 9 minus 1. Seven times negative 2 raised to the 8th. And we get, it's a positive, which makes sense because negative 2 to the 8th raised to an even power will make it a positive number. 1,792. Number 8. What is the 5th term? We know the first term is 9. The common ratio, 9 times what would give us 27? Let's say it's 3. And we can always check it. We do 27 times 3, we get 81. So it checks. Now the common ratio is 3. The first term is 9. Find the 5th term. So a sub 5 is equal to the first term of 9 times 3 raised to the 5 minus 1. Of course, we could always see, we know we already see the numbers here. We see the first four terms. Here's A1, A2, A3 is 81, A4 is 243. If we would do the equation, we would get the same answer. If we did 243 times 3, we would also get the same answer, which I'll do that right here. What is 243, the fourth term, times 3? So we get a 9, a 12, carry the 1, and a 7. So the fifth term will be 729. Now, the reason why we do n minus 1 is because we have the first term already included in the equation. So if we did not do that, we would always be off by one term number. And that's why there's the n minus 1 in the equation. Next one, what is the 13th term? Well, the first term is negative 2. The r value, what are we multiplying by to go from negative 2 to 4? Negative 2 times negative 2. So the common ratio is negative 2. To find the 13th term, we will do negative 2 times negative 2 to the 13 minus 1, which of course is 12. Let's clear it here. So we have a negative 2. So I hit 2 plus minus on your calculator, times, parentheses, negative 2. So you hit 2 plus minus. That gives you a negative. Close the parentheses, and we're going to raise it to the 12th. We get a negative number, negative 8,192. Now, why is this answer negative when it's negative 2 to the 12th? Well, because there's a negative in front of the equation in this case, in the very beginning. So it's a negative times a positive, which is still negative. Number 10. Martin got a job at a starting pay of $8 per hour. His boss told him if he works hard, he can get a raise each year. And this table here on the right shows his wages for the first few years, years 1, 2, and 3. Find Martin's hourly wage after 6 years. So we'll assume here each time he's getting the same increase. Well, it's not arithmetic, so we're going to be multiplying by r each time. So we're going to have to figure it out. This is a geometric sequence, so he's getting a percentage, the same percentage increase each time. And that's why we're multiplying when it comes to a percentage increase. That gives us a common ratio r. So 8 times r is equal to 960. So we divide both sides by 8. Let's see here. I'm going to do a little math here. I'm going to move 2 decimal places. So I got to add 2 zeros to the 8 on the bottom. Now we're going to reduce this. 960 over 800 reduces to 96 over 80. I canceled a 0. Now these are even. I'm going to divide both of them by 2. So half of 80 is 40. Half of 96 is 48. And I can divide these by 2 again. 24 and 20. 12 and 10. 12 divided by 10 is 1.20. This means, because 1 is the original salary, 100% is your original. This means each year he's getting a 20% increase in his salary. A 20% increase, which is actually a common ratio of 1.20. So the common ratio is 1.20 or 1.2. The first term is 8. It says find the sixth term. The first term is 8. We're increasing about 1.20. And let's find out how much it is in year 6, which is, of course, 6 minus 1. So let me clear this here. We're going to do 8 times, parentheses, 1.20. Of course, that 0 there is unnecessary. Even the calculator took off that 0. And we're going to raise it to 5 because it was 6 minus 1. And he'll be making, and this is a money problem. We're going to have to round it 2 decimal places here. So we'll round it to 91 cents, not 90 cents, 91 cents. So it's 1991. So he will be earning $19.91 an hour in his year 6 of employment, which is pretty good. That's a good start. It's a good increase from $8. Very few jobs will pay a 20% increase each year unless they're starting you off at a low salary. Now, some companies will give you a 20% increase after the first year. I know engineers who, when they got a good starting salary, in their first year they got a 20% increase as kind of a bonus, so they wouldn't leave the company. But then after that, their increases were substantially smaller. Well, that concludes this lesson.